Your goal after watching this video is to be able to use the distributive property and know why it works. Please be filling out your note sheet as we go. This first part is not for your notes, it's just a quick review. Anytime you see a math problem, I want you to be thinking order of operations. So anytime you're simplifying an expression, order of operations, order of operations, order of operations. So a quick review of that since it's so important. Always start by trying to do what's in the groups first. Groups always come first. Then exponents, along with this, but we won't do that in 6th grade, okay? So then, after the groups, check out the exponents. See if you can simplify those. Then, you're going to multiply and divide. Please remember that multiplying and dividing are equals. You can divide before you multiply. Divide comes first in the problem. Finally, last step, last thing you should do should be to do any adding and subtracting, or subtracting and adding. Again, these two are equals, so if subtracting comes first, do that first. If you need to write any of this down, feel free to pause and write this in your notes if you don't think you'll remember. Otherwise, I think most of you have order of operations pretty well. Okay, so now here's where we're going to start talking about the distributive property. We're going to look at this first example up top. All right, and first we are going to be good math students and a good math teacher, and we are going to do what we're supposed to and follow the order of operations. Okay, so first, check out what's in the groups. Can I do that? Yeah. All right, 3 plus 4 is 7. Then take it times this 2. 2 times 7 is 14. So we know, because we followed the math rules and we did order of operations, that this expression is supposed to equal 14. Now, we're going to be a little rebellious, okay? We're going to try something else. We're going to say, hey, this 2 out front, that is being multiplied by this whole group, right? You see that? There's nothing between the 2 and the parentheses, so that means multiply. So we are going to multiply that 2 by everything in the group separately. So first we're going to multiply or distribute the 2 to the first term. We're going to take 2 times that 3. Now I have an adding symbol, right? But that 2, it doesn't just say 2 times 3, it says 2 times everything in that group, and there's something else in that group. There's a 4. So we're going to multiply or distribute that 2 to the 4. Okay, so I just took 2 times both things in the group. 2 times 3 is 6. And 2 times 4 is 8. If I take 6 plus 8, what do I get? Doing the rebellious method, not following the order of operations. I get 14. I get 14. Hey, it's 14 again. All right, so me being a math rebel, you following along as I was a math rebel, it worked out for this problem. But sometimes things work out in math and they just are coincidences. So we're going to try another one. All right, first, be good math students with me, good math teacher. We are going to follow the order of operations. Do you like how I'm neutral? I'm not doing, I could highlight this purple, but I won't. I could highlight it green, but I definitely won't do that. So we'll go with blue. We're going to be good math students. Order of operations says, do what's in the group first. 4 minus 3 is 1. 2 times 1 is 2. So since we follow the order of operations, we know that we're right. All right? The answer to this expression is 2. But now we're going to be math rebels, and we're going to not follow the order of operations. We're going to say, hey, this 2 out here is being multiplied by this whole group, by everything in the group. So let's multiply it by everything in the group. First, we're going to take the 2 and multiply it by the 4. We have a subtraction symbol. Now we're going to take this 2 and we're going to multiply it by 3. We're going to distribute the 2 to the 3 also. All right, so 2 times 4 is 8. 2 times 3 is 6. 8 minus 6, oh, check that out, 2 again. Sometimes it pays to be a rebel. Don't tell your parents I said that. All right, so here it appears that when you have a number outside a group, a number being multiplied by a group, you can either do what's in the group first, which sometimes you can, or you can take the outside number times everything in the group separately. And I know some of you, I could name you, but I won't. I know some of you are sitting there saying, well, why would we do it both ways if I could just do what's in the group first and then multiply it by 2? Or up here, I could just do what's in the group first and then multiply by 2. Why would we do the other way? Sometimes, especially in algebra, you're not going to be able to do what's in the group first And that's why you might want to do the other way that we just did. So there's your little teaser. This is the first thing I need you to write in your notes. Distributive property. Distributive property says that you can multiply or distribute the thing right outside a group by every term in the group. Alright, so here the thing outside the group is this 2, and you could multiply it by every term in the group. The reason why you want to do it in this case is because you can't add x plus 5. X times 5 is 5x, but that doesn't say times, it says x plus 5, which you cannot do. Please make sure you get this definition written down. If you need to pause, you can. I'm going to move on. All right, so distributive property and mental math. We're going to find the product of 8 times 53. So I'm going to start by writing 8 times 53. Now in my head that would be pretty hard to do, but I know that 53 is the same as 50 plus 3. So we're going to break this number down into something that has one really nice number, all right, which is 50. If it was 68, whoops, you could break it down into 60 plus 8. If it was 72, you could break it down into 70 plus 2. If it was 109, you could break it down into 100 plus 9. Then we're going to take 8 times 53. We just wrote 53 in a different form. We wrote 50 plus 3. So first, we multiply 8 by the first term in the group. So we're going to take 8 times 50, right? And, we have a plus sign here, we're going to distribute the 8 to everything else in the group. We're going to take 8 times 3. The really nice thing here is that in my head, I could tell you 8 times 50 is 400. Really simple. Plus, 8 times 3, I could also tell you that in my head. Pretty simple for me. 8 times 3 is 24. It would be super embarrassing if I said like 36 after I told you how simple it was for me. But I did it, all right? Then I just add 400 plus 24 is 424. So one way to make mental math a little easier, and this is what I do. I do this in my head every day. When I'm trying to multiply, I always break down the bigger number into 2 easier numbers. Pause if you need more time. Use the distributive property to find 1/2 times 2 3/4. Okay, already I saw this problem. I'm a teacher. I saw this problem and I cringed because it's fractions. And I hate fractions. I hate multiplying fractions. I hate dividing fractions, but really I hate adding and subtracting fractions. Anyway, we're going to make this easier. 2 3/4. Couldn't I write that as 2 plus 3/4? And we need to take 1/2 times that. So I'm going to distribute the 1/2 to everything in the group. I'm going to multiply the 1/2 by every term in the group. So first, I'm going to take 1/2 of 2. And then I'm going to take 1/2 of 3/4. All right, well, 1/2 of 2, what is half of 2? 1. All right, plus 1/2 of 3/4. Remember when you're multiplying, you multiply your numerators. 1/2 times 3/4 equals 1 times 3 over, it's a 4, not a 7. There we go, over 2 times 4. So that would be 3/8. 1 plus 3/8, well, ladies and gentlemen, that's just 1 3/8. So the distributive property can be helpful in breaking down problems, making mental math multiplication much easier. We are in example 3, and we haven't even hit 10 minutes. I'm doing okay. All right, use the distributive property to simplify the expression. So part A, this is really where distributive property is helpful, because if I'm a good math student or a good, proper math teacher, I would follow order of operations. So I look in my group and I see n plus 5. I can't take n plus 5. I don't know what n is. So I can, since I know the distributive property works, I can distribute that 4 to everything in the group. I can say, okay, well, distributive property says that I can take 4 times n, and I can also distribute the 4 to the other thing in the group, 4 times 5. And then I would say, all right, 4 times n, that did not work. All right, 4 times n is I thought I had the highlighter there. 4 times n is 4n, plus 4 times 5 is 20. Done. Because then I can't add n's plus 21. I can't add 4n plus 20 because I don't know what n is. All right, next example. All right, like a good math teacher, I will look in the group first. Germ does look in the group first. So I do 2y minus 3. I can't do that because I don't know what y is. I can't take y as minus 3 ones. I just can't. So since I can't do what is in the group, see, I tried. All right, it's like if your mom tells you to clean your room and she comes back from work and your room's not clean and you're like, I tried, but the door was locked. All right, so you tried to do the right thing, you just couldn't. I tried to do the right thing by doing what's in the groups first, but I just couldn't. So I'm going to take my 12 and distribute it to everything in the group. So I'm going to take 12 times the first thing minus, I have subtraction here, I'm going to take 12 times the second term as well, 12 times 3. Okay, so first, 12 times 2y, 12 times, if I have 2 y's, 12 times, all right, so that means I have a y and a y. There's 2 y's, and I have that 12 times. So imagine I'm going to write down 12 sets of that. How many y's would that be? That would be 24 y's. Subtract, right? 12 times 3, which is 36. Done. All right, you can't add or subtract a variable with a constant, so I just can't do that. Part C. All right, so like a good math student, or like a good math teacher, all right? I'm going to check the groups first. Hey, finally I'm rewarded for doing the right thing first. I can take 6 plus 2. I can commute. I can use the commutative property to put the 6 and the 2 by each other. So I'm going to write 9 times 6 plus 2 plus x. Remember, changing the order of just the adding part doesn't matter. So 9 times 6 plus 2 plus x. I know 6 plus 2 is 8. And then I can distribute, since I can't add 8 plus x, I can distribute or multiply 9 by everything in the group. So 9 times 8 and 9 times x.
If any staff members are parked in front of the common stores, the ones that we normally come in, we'll need you to move your vehicles. We have the fruit delivery today. Thank you.
And there's a little special announcement for you. All right. So anyway, after I distribute the 9 to everything